CNT120, Chapter 5. We're into the troubleshooting tools section of dealing with our cabling. The first one they mention is our toner and probe. Our toner and probe kit is really helpful for locating a cable. Here's your toner and probe. This is similar to one we have in our lab room right here. I can hook the tone generator onto a wire or cable. It could be an actual cable terminating a patch panel or a cable terminating to an outlet in a room. And then the tone locator or the probe part here, actually as I hook the toner on, it actually sends a electronic signal across the wire. And the probe, or the tone locator here, the probe, as I move that one near the cables, the one that has a signal on it actually picks it up and actually emits that sound out through the speaker here. So where this comes in handy, especially in networking world, this is something that kind of came from phone world, trying to find a wire pair that I need to maybe disconnect and re-terminate somewhere. I can do the same thing in data cabling. If I have data cables maybe terminated incorrectly or labeled incorrectly, and it's pretty easy to have that happen, I can put the toner on, an outlet, and as I go to the closet, I can take the probe and go right down the patch panel and find that cable and go, oh, there it is. Oh, yeah, it was supposed to be an 8 and it's terminated the 9. And I can relabel things. I might be able to just relabel and fix the problem right then and there. So this is very helpful for finding a cable that might be mislabeled, or maybe it's not terminated right. I can still find the cable and look at it and see, maybe I'll re-terminate. That's where this is really handy, this toner and probe. Here's another example of a toner and probe. Multimeter. This is handy for doing some basic electrical measurements. Measure voltage, check for proper amount of voltage, maybe check for an open in a wire or circuit. This is your multimeter here, and it's actually able to do a couple different tests, hence the term multimeter. Voltage is resistance. You can even do continuity. That's a little speaker tone there is for as well. For cabling, the go-to tool we're going to run into is our cable tester, our continuity checker. And the continuity checker is, think of it as like a little electrical circuit tester. It's going to send a signal through the wire and look for it to appear on the other end of the wire. Where does it appear? And if it actually shows up there, it usually puts a little light on to say, yep, the signal got there. So these continuity checkers, these are the ones we have in our lab room, will send a signal out, maybe the one wire, and it gets to the other end. This is the other end. This end loops it around and sends it back, and it looks for it to come back on the number 2 wire. And if it does, it lights it up saying, hey, the 1-2 wire pair, we have a complete path out to the other end and back. And it does the same thing on the 3-6. Goes out to 3, comes back to 6. Yeah, we got a complete path. So it literally lights up these light for each wire pair, letting you know it has a complete circuit. So here, if I have a good cable, it actually starts showing up that all 4 wire pairs are good. This is the sender end here. This over here is the receiver end here. And again, it lights up on these ends over here, and it shows a little light saying pass. Yep, all 4 wire pairs look good. So it's just looking for a complete electrical path, on this case, all 4 wire pairs. That's all it's doing. That's all it really can do. If I have a problem, though, I can actually use, most of these have some kind of button on to look for a fault. This one actually has a fault check that I can go through each wire pair individually. So I test and it comes up fail. If I start pushing that little fault check button, it goes through each pair individually, and it'll come up with, hey, 4, 5, we have an open. There's a break in it. Now, it could be there's a cut in the wire, or it could be one of the ends is not terminated right. That's up to me now to try to look at those and figure that out. But this will at least let me know I don't have a complete circuit on the 4-5 pair. That may be why your link is not working. If I have a short, again, I go through the fault check. It might show, hey, this 1-2 is shorted. Come over here to reverse pair. If 2 wires are flip-flopped in location, it's going to say 7-8 got flip-flopped, the brown pair on the end of my cabling. So this is going to give me a clue as to what might be wrong. Some can actually show, some continuity testers can verify wires paired correctly, not short, exposed, crossed. Fiber optic continuity tester, it literally is going to issue a light pulse and going to determine where that pulse reaches the other end. Okay. So I typically want to test any of my cables. I don't just kind of assume. I test them to make sure that they're functioning correctly. It's a low cost item to replace. It's a lot cheaper to replace a patch cable than it is an entire network card or a switch or something like that. So it's a real easy thing to try to test and troubleshoot. Here's another example of a continuity tester. One of our other toolkits in the room has one that looks like this, and I actually have one like that in my own toolkit itself. There is meters out there that will actually do a wire map. It'll actually map out the wires and show you graphically what's going on. Sorry, Mr. Brown's pictures are a little blurry. I actually took pictures of the wire map meter in our lab room, and I got my pictures a little blurry that day. But here is the wire map meter, and when I test the cabling, this I'm testing a patch cable. It loops back to itself. It shows all the wires are wired straight through. There's a straight through cable, nothing wrong. Here's a wire map of a wire break. One of the cables is broken somewhere. In this case, it's broken right near the source end. Right near the source end. That's why it says it's less than so many meters. Here is a short between two wire pairs right there. It's showing, hey, there's a short between the 1 and the 2 cable. Here is the 2 wires flip-flopped, reversed. The white, brown, browns got reversed in the termination somehow, which is really easy to do. And that's going to show the reverse pair. So each one of these is giving me as a clue as to what the problem is. The continuity tester was giving me a clue. This is giving me a little bit more information. Now these meters are more expensive. These can be in the $500 category versus the continuity testers might be in the $50 to $100 category. Just to give you a little price difference in the meter. But my wire mapper and continuity can't tell me anything about the performance of the link. All it can say is it looks like it's okay. I need a cable performance tester to let me know, is it able to carry the gigabit speeds? Do we have too much attenuation? Do we have too much crosstalk? And now I need more specialized tools to be able to do that. And some of these also have the ability to do distance measurements. That's your time to main reflectometer, TDR. These back here, let me show you these guys real quick. These guys here actually have a small TDR built into it because it's giving you the cable length. It's actually giving you the cable length. It's kind of measuring the amount of time it took for that signal to go across the cable, and from that it's able to infer it's about this long. It's about this long. That's the TDR part of this, which is really helpful for checking terminations. If I'm going to check anything performance related, I need copper cable certifiers, if you will. And they make them for copper and fiber too. This is very similar to one we have in our lab room. This would be the Fluke counterpart. This is Ideal brand, this is Fluke brand. Again, I don't get free t-shirts, just showing you examples. This is actually able to do a battery of tests, a whole series of tests to let you know, is it wired correctly? Is it too long? How much signal is lost across it? Is there too much crosstalk? And it literally does a whole battery of tests, and if it passes all of them, it can say, yes, this cable should be good for use in your network. And we do that in our cabling class. Here's the fiber optic counterpart to these, the fiber optic counterpart to both of those. Last but not least, if I'm dealing with fiber optic cabling, I might need a power meter. This will let me know how much of my signal is getting across the cable, and it usually comes in 2 pieces, or I at least need a light source of known strength to go across the cable, and this will measure how much is getting to the other end. This will let you know if I'm having a lot of signal loss, what it might be, and as you see here, it's measuring that in decibels. So many decibel signal loss over that distance. So there is some of my troubleshooting tools.